Please refer to question number 4 given in the question set. Actually, this is a ketone. This is a diethyl ketone. And the IUPAC name for this compound, as you all know, will be 2 plus 1, 3 plus 2, 5. So it will be 3-pentanone. But for our practical purposes, for our routine name, a trivial name like diethyl ketone can be used. What happens when it is treated with in the presence of a weak alkali? What happens when it is treated with sodium cyanide and in the presence of ammonium chloride? This is a very simple reaction in which the two ethyl groups will be retained as it is, will be 2C2H5, and then we will have a cyanide attached to it because this is an electrophilic center. This is an electrophilic center. This is a ketone. This is an electrophilic center. Therefore, the cyanide will attack this. Therefore, the cyanide will attack this, and then after that, the NH2 will also be attached to that. That is actually the product that is obtained. This is actually a product. This is not a chiral center because two similar groups are attached. 4 different groups, it looks like they are attached, but actually the two groups are similar, 2C2H5, and this is actually the product obtained, and this is a very simple question that is given in this question number 4. Now we will go to question number 5. I will remove this question number 4. We have discussed this. Now we will discuss about question number 5. Question number 5 is a very simple and interesting question. This refer to question number 5 in the question set. Question asked is, how will you convert C5H11COOH? Actually, C5H11COOH, 6 carbons are there, 5 plus 1, 6 carbons are there. It is known as hexanoic acid. And how will you convert this to pentanoic acid? That means how will you go down by 1 carbon atom? This is 5, 5 plus 1, 6. This is 4 plus 1, 5. 4 to 5, we are going down. The same functional group, COOH, is being maintained. So the steps that are given are, you start with the hexanoic acid, C5H7COOH, and lithium aluminum hydride, as you know, is a very powerful reducing agent. Therefore, this will get, lithium aluminum hydride will reduce to give rise to, this will remain there as it is. This will not get affected, C5H11, but this COOH will get reduced to the alcohol. Lithium aluminum hydride is such a powerful reducing agent, it will reduce the esters to the alcohols, acids to the alcohols, aldehydes to the alcohols, everything to the alcohol stage. So it will get reduced to the alcohol. So when you get this alcohol can be, can undergo dehydration because this is a primary alcohol, this is a terminal alcohol. Therefore, this will lose a molecule of water to give rise to C4H9, CH3, CH2, CH, double bond. There are 6 carbon atoms here. Therefore, it will be, you have this CH2 and one more, 4 carbon atoms will be there, and then the 5th carbon atom, it will form a double bond like this. So this OH and then one more hydrogen atom from here. Therefore, this will become 1, 2, 3, 4, 5. Then this N carbon atom will remain like this. This olefin will be produced. This is in other words, we have converted an acid to an olefin through an alcohol. Alcohol is obtained from the acid by means of lithium aluminum hydride reduction. This lithium aluminum, this alcohol that is obtained being a terminal alcohol will give a terminal olefin according to Seid's rule. There is no other choice. If the alcohol group is here, this can give rise to a terminal olefin as a minor product and an internal olefin is a major product. But this is the major product or the only product that is obtained in this particular case. Now, we know among the reactions of olefins, this gets cleaved by means of hot alkaline permanganate. These conditions are very important. Supposing you make use of Bayes reagent, you will get a diol here. You get a OH added here. But the double bond gets cleaved. The compound gets cleaved at the position of the double bond by means of hot alkaline permanganate to give rise to this acid. This will become a COOH. So what will actually get is CH3, CH2, 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 then this will become COOH. So this is exactly what we want there. C5H11, this is actually, and not this compound, and this is the compound that what we need, C4H11, C4H9, COOH. And so this is the first step in the reaction. Subsequently, it is reduced to the olefin, converted to the olefin. Olefin is being broken, olefin is being cleaved to give rise to the acid. One of the conditions for converting the olefinic double bond to an acid is to treat it with hot alkaline permanganate. Acid permanganate will not do the reaction. The CH2OH or anything else will become a diol, or it will become an aldehyde, or it will go through various stages. But this is a specific reagent, the hot alkaline permanganate. Supposing we have a carbon-carbon, a double bond like this, then when you treat it with hot alkaline permanganate, this part will become an acid, the other part will also become an acid. That is what is being attempted here.